about logs. I'm recording this so I can send it off to Australia for our friend Darcy. Okay, so we have seen most of these things kind of, but not so much in the wild. Like we've gone through some of these properties academically. So no matter what I have, as long as it's a legal base, remember that my base is not the log a of 1 equals 0. What that's really asking 0 is a to what power equals 1, and of course a to the 0th equals 1. So that is kind of the corresponding property of exponential functions. This is saying a to what power equals a. Well, that's really saying that a to the first equals a. So there's your corresponding exponential one. This is a little hard to do. We've done it where we say, oh, the log base a of m is asking me what power I would raise a to in order to get m. And once I find out whatever that number is, I raise a to that number. Oh, so I don't really even need to know what that number is, what the log base a of m is in order to solve this. A to the power that when I raise a to, I get m, gives me m. I'm just gonna put a little check mark there. All right, another one here. The log base a of a to the r equals r. They're saying a to what power equals a to the r. Well, a to the rth power equals a to the r. A to the x equals a to the r. Oh, well, x equals r. If we have two things which have the same, well, x and y are the same, log base a of x can only equal log base a of y if x equals y. So for example, if I have 2 to some power equals 9 and 2 to some other power also equals 9, well, then they really aren't other powers. They are the same power. And this looks to be kind of the converse, to use a geometric word. Let's actually quit the academic look at it and see how it works practically. What is the log base 4 of 1 then?
0.
0. Yeah, we're asking 4 to what power equals 1? 4 to the 0th power. The log base root 7 equals root 7 to the 10th. Well, that just means that the answer is
10.
Equals 10. Yeah. So I'm saying root 7 to what power is the same as root 7 to the 10th? Oh, root 7 to the 10th power. Thank you so much for asking. Over here, my answer, nice and quick, is
20.
20. Okay. Just for the fun of it, the log base 6 of 20 would be a number somewhere between 1 and 2. 6 to the first is 6. 6 to the second is 36. 20 is somewhere between 6 and 36. Maybe it's like 1.5-ish. I don't know. So what am I doing with that 1.5-ish? I'm taking 6 to the 1.5. Oh, so I'm getting a number between 6 and 36. Makes sense that I would get around 20. Here they've changed it up a little bit. It's the same problem as before, because instead of saying log base 6, they're saying log base e here. E to the log base e of 1.5 is just equal to
1.5.
1.5, and we're done. All right. Down here, what does x equal?
12.
X equals 12. We're saying to e to some power equals x, and e to some power equals 12. Well, if those two things are equal, then x and 12 have to be equal. Throwing a little bit more algebra into it this time. Now I get that 2x plus 1 equals x. If I subtract, I get that x equals -1, and I guess I'm done at that point. And even more algebra, this time I can say x squared minus 6 is equal to 10. Oh, so x squared is equal to 16. and x is equal to
4.
I heard a 4.
4. 4.
What about a plus
Plus or
or minus?
minus. Plus or minus.
4.
I think the plus or minus. Now let's check it out. Sometimes it gets a little dicey because I'm not allowed to take the log of a negative number. But if x is -4, am I ever taking the log of a negative number?
No.
No, not at all. Okay, even if it's -4, -4 squared, which I do before I take log, is now 16. 16 minus 6, still positive. So far, so good? All right. More properties of logs. Now, these are the fun ones. These are somewhat new to us, I would have to imagine. Let me do an example before I do a proof. Let's take the common log of, I don't know, how about 1,000? Is that true that that is the common log of 10 times 100? Okay, so according to this rule here, that they're saying that that is the common log of 10 plus the common log of 100. What is the common log of 10?
1.
1, yeah. We're really, the common log is the log base 10. We're saying 10 to what power equals 10? 10 to the first power. What is the common log of 100?
2.
2. All right. So 1 plus 2, that's 3. Well, if I went right to the beginning, what is the common log of 1,000?
3.
3. They're really asking me 10 to what power equals 1,000. Sound okay? All right. That wasn't a proof. That was merely an example. So let A equal the log base A of M and B equal the log base A of N. So if I did A plus B, I'm really doing the log base A of M plus the log base A of N. Well, let me rewrite these a little bit if you don't mind. How do I rewrite this one as an exponential function?
A to the x equals m.
A to the what now?
A to the A.
Oh, a to the a equals m.
Big A, yeah, it's kind of unfortunate that they use those. Equals M, and over here I'm going to get A to the B equals N. Okay, what would happen if I were to multiply these two things together?
A
What-
plus b, or a to the a plus b.
Yeah, M times N equals A to the A times A to the B. Well, you know the rules. That is A to the A plus
Can you
B.
put it over?
Yeah, absolutely. Sorry. Okay. Now I'm going to rewrite this in logarithmic form. That would be M times N. Huh? All right, that would be the log base A of Mn equals A plus B. And
Do we have to
again, A plus B is this over here. Did we prove it?
Wouldn't the base be a lowercase a and not an uppercase a?
Sounds wise to me. Make that into a lowercase a.
Oh, so Mr. Reeves,
Mm-hmm.
on the test, there's like not a question similar to.
Not everyone here is taking the test.
Oh, okay.
Okay, come to an office hours, ask me afterwards, but yeah, not right now.
Mr. Reeves,
Yes.
so like I understand like I'm seeing like what you're doing with the problem, but I'm just confused how you know what they're asking.
Well, this wasn't really a problem. This was a proof. They wanted me to show that this must be true. If I really had sat down and thought about it and worked on it, maybe I would have done like a 2-column geometric type proof. But what I did was I showed that this has to be the case. That anytime you have this, A plus B, you end up with this. In other words, anytime you have the log base A of m times n, it's equal to the log base A of m plus the log base A of n. And again, down here at the bottom, we'll get a chance to see these in the wild. Aiden, yeah, what's up?
Is it possible for you to ask this on a test? To do
To ask you to prove it, it's possible, but very unlikely.
Okay.
Much more likely we're going to be doing stuff like you're going to see at the bottom.
Okay.
In fact, I, as a general rule, do not prove this one because I find these to be really the same rule. Okay. One is when you multiply two things, you add the logs. When you multiply the arguments, you add the logs. The other is when you divide the arguments, you subtract them. Tomato, tomato. It's really the exact same proof. Not real interested in doing that. Let's skip down to here, and in part C, again, I'm going to do an example. So let's do the log base 2 of, I don't know, something like 8 squared. Well, I know what that is. That's the log base 2 of 64. What is the log base 2 of 64?
4.
5.
Getting warmer.
6.
6 is the right one.
Okay.
Right. So 2, 4, 8, 16, 32, 64. So 2 to the 6th is 64. The log base 2 of 64 equals 6. Well, what they're claiming is that that is the same thing as take that exponent and bring it down in front. 2 times the log base 2 of 8. Well, what is the log base 2 of 8?
3.
3. Absolutely. 2, 4, 8. Oh, 2 times 3, it equals 6. So that, again, not a proof, but does it seem more or less legit?
Yeah.
Okay.
Mr. Reeves,
Yes.
so on the first proof, I'm confused because you're basically saying that are you saying that the log m of n, log base A m of n is equal to log base A of m plus log base A of n?
Yes, 100%.
But one is being multiplied and one is being added. So that's where I get.
I know, but here it's the arguments which are being multiplied and the logs which are being added.
Oh, okay.
So it's not like log base A of m times n equals log base A of m plus n. Nah, it's the whole logs that we have to do.
Okay.
All right, so we were going to try to prove this. Again, they're using these A's. Originally, someone yelled out X. Would it make people a little bit happier if I turned this big A into an X?
Yes.
I heard a yes in there. Great. Then I'm just going to do it. That way I don't have to worry about that whole lowercase, uppercase thing. Let's write this exponentially. And I'm going to throw up another thing here. I'm going to put it in. So I'm going to say that A to the X equals M to the B. Okay. Then I am going to take the bth root of both sides. Okay. So I'm going to write this as the bth root of this and the bth root of that. Okay. What's another way of rewriting my right-hand side without this bth root floating around? I get A to the
1 over b.
X over B.
X over B. I heard a 1 over B and you were close, but X over B equals M. Now let's rewrite it without within the log function, sorry. And I am going to say that the log base A of m equals x over b. I did something funky. Equals x over b. I made a mistake somewhere. Oh, yeah. This was equal to that. Great. Perfect. So if I multiply both sides by b, I get b times the log base A of m equals x. Notice that that's what x is. This is what x is. I'm going to put these two things together with the transitive property and say that the log base A of m to the b equals x. Well, x also equals this, equals b times the log base A of m.
Could you move it down, please?
Yep. Moving, scooting. There you go. All right. Again, those are the proofs of these things. I would hate to ever be telling you math which I didn't believe, which we couldn't show as true. But is it truly necessary to know how the engine works to be able to drive it? Not so much. Let's actually get out there and do some of these. So expand. This is what you will be seeing on homeworks, on tests, on quizzes, something which looks like this. They ask me to expand this. So this is the log, I'm going to do it in 2 steps. Base 2 of x squared plus the log base 2 of y. 100% correct, not complete yet. What can I do with this exponent?
Put it in front of the log, or
Put it in front of the log. 2 times the log base 2 of x plus the log base 2 of y. Sound all right?
Mm-hmm.
All right. We skipped over up top the division subtraction ones.
Is that just an inverse?
It's kind of inverse-like-esque, one might say. I'm going to say that this is the log base 2 of x squared. This time I'm going to say minus the log base 2 of y. And as a final step, again, that exponent, 2 times the log base 2 of x minus the log base 2 of y.
Mr. A question.
Yeah.
If the y had a squared, would
Yep.
you put the 2 before the log base 2 of y?
Yes. 100%. Or if they both had a square, I could pull it out front and say 2 parentheses log base 2 of x minus log base 2 of y. End parentheses.
Okay. Thank you.
All right. C. I'm going to let you guys do it. I will I'll take attendance. And we are just missing Darcy, of course. Okay. So hopefully you got something which looked like 2 times the log base 2 of x plus the log base 2 of y minus the log base 2 of z. Does that look familiar? Got a nod. Got some nods. Yes, yes, yes.
So
Yeah.
if you so you add it if it's on top and you divide and you subtract if it's on the bottom.
Yeah, more to the point, you add it if they're multiplied together, you subtract it if it's divided.
Okay.
Another one here, getting a little bit on the sneakier route. I'm going to say the log base 2 of x squared times x minus 1 to what power?
1/2.
To the 1/2. Is that coming from my stereo? Randomly, it started playing Desperado by the Eagles. I don't even know where it's coming from.
Nice.
Oh, someone's playing around with the Alexa upstairs. Got it. Log base 2 times log base 2 of x. I got to turn off my Alexa. And the log base 2 of x minus 1. Alexa, announcement. We can hear the music downstairs. Actually, I wired the Alexa to the light switch. If I turn off the lights, I turn off the Alexa.
Mr. Reeves, you just turned on my Alexa.
Yeah, you made
Yeah,
Miles to make the announcement.
Make the announcement. Sorry. We are a multi-Alexa family over here, and we use it as our intercom. Okay. Over here we've got I guess 3 log of x plus 2. And I didn't say log base anything, so it's implied that I have a base 10 minus 1/3 the common log of x. Now it's always tempting here that we have that x plus 2. Oh, I have a rule which involves addition, but not in this case. That's nothing I can do. There. All right, a couple more of these guys. Natural log of x minus 2 minus the natural log of x, and also minus 7 times the natural log of x plus 5. And unless we want to get super sneaky, I don't think there's much we can do with D. I am not into getting that sneaky. Let's just write D's answer as what it had originally. I mean, if we wanted to get super sneaky, we could find a common denominator, make this into a complex fraction, and do stuff from there, but I'm okay. All right, next up, they're telling me that the natural log of 2 is exactly A, the natural log of 5 is exactly B, and they ask me something about the natural log of 10. Well, what's another way of writing 10?
Log.
2 to the
Like
No,
AB.
wait.
AB, yeah. Kind of that AB bit. Another way of writing 10 is 2 times 5. Will that do anything for us? Can I write this now?
Yeah.
As the natural log of 2 plus the natural log of 5? What's the answer to my question?
A plus B.
A plus B. There it is. Boom.
Mr. Santi.
All right. Natural log of 5 divided by 2. So that should be the natural log of 5 minus the natural log of 2. What's my answer this time?
B
A
minus
A.
A
Oh.
minus B, or B minus A? B minus A. Ooh. B minus A. Awesome. Natural log of 64.
A to the 6th.
Oh, all right. Close. Close. I like where you're going there.
2 to the 6th.
All right. Natural log
Yeah,
of
natural log.
6, which can be written as 6 times the natural log of 2. Oh, the natural log of 2 is A. My answer is 6A.
Wait, could we have also done like the natural log of 8 squared?
Sure, you could have done the natural log of 8 squared. So I could have done the natural log of 8 squared. But how would I have gotten the natural log of 8?
And wouldn't you do 2 natural log 8?
Okay, so still, what's the natural log of 8, though?
Oh.
Eventually,
Oh, I guess it's 2 cubed. And then you get a 2 out. Okay.
so same idea, but I like it. I mean, like this one, for example, I could write it as the natural log of 2 times 2 times 5, or I could write it as the natural log of 2 squared times 5. This one, I'm going to say, oh, well, that's natural log of 2 plus natural log of 2 plus natural log of 5. This one, I would say, oh, or that's 2 times the natural log of 2 plus the natural log of 5. But aren't these the same thing? So I get the same thing regardless. I think something like that for that last one.
Well, you bring the 1/4 down because it's in front of this. Yeah, okay.
Yeah. All right. Pretty good. Pretty good.
Wait, if we were, because you skipped like the middle step. Can you do the middle step for me? Would it be 1/4 natural log of 2 to the 3rd?
I kind of missed that. What was the question? I'm sorry.
So the step in between for letter E,
Mm-hmm.
would that be 1/4 natural log of 2 to the 3rd, and then plus 1/4 natural log of 5?
Sure, we could write it that way. I'm perfectly happy if you arrive at the same answer or something similar, like maybe you ended up with 3/4 A plus 1/4 B, something like that.
Okay.
And it looked like you did the steps in a slightly different order, but that's perfectly fine. All right. How are we feeling about this?
Good.
Good, good, good. Okay, that covers it for today. Today is Wednesday. We have class tomorrow on Thursday. We have class again on Friday. I'm trying with some of my classes. We don't have like a wrap-up quiz or anything. I'm trying with some of my classes just to, have a little bit of a fun-ish day on Friday, which entirely is a possibility here. Let me know if you guys have any thoughts on what we could do to make this, I know this whole like last 2 weeks has been kind of a bummer for me. I'm assuming it's been kind of a bummer for you guys. This isn't really how I like spending my time. I got a half a nod there. I guess the rest of you are enjoying your time in isolation. But yeah, it's kind of a bummer. So if you guys have ideas on what you might want to do on Friday, do let me know. Other than that, we're gonna sign off. I am going to email about 2 of you, and maybe we should have a little bit of a chat online. So if you get an email in the next couple minutes, it'll probably have another breakout room for you guys to jump in on. Was there anything else that I could help you guys with before? Yeah.
For our homework, should we send you a picture of it?
That would be fantastic. Please do that.
Okay.
Wait, is it on the hub at homework?
I haven't put it on the hub. Let me chat with 2 of my friends first, and then I will put it up there on the hub. And if I don't in the next like 10 minutes or so, please send me an email to remind me. Other than that, I will see you guys on the tomorrow side of things. Yes?
Okay.
All right. Sounds good.
Bye, Mr. Reed.
Bye. See you in a little.
Thank
See
you.
tomorrow.
Thank you.
Thank you.
You bet. You bet.